Hello, and welcome to this episode of the series. In the last episode, uh, I had to just kind of like ac accept the fact that I wasn't having the amount of control over the actual rendering of the text as I wanted to, and I realized that something was up. Um, as I've mentioned in the previous episode, um, I've taken inspiration from the BrainstarSoft tutorial on how to render text in DirectX12. But it seems like his way of doing things and mine have diverged. Uh, and I realized that it might pertain to the winding order of the vertices, since we use instance drawing and we use the pipeline to draw 4 vertices, and the order in which we do it is determined by the pipeline. And since I'm using Blender models, which are actually um, in a OpenGL based coordinate system, all the models end up having counterclockwise winding orders. And let me see, let me just remove this. Uh, and that means that, for one, textures need to be flipped to accommodate this winding order. Uh, and secondly, it means that the way that we draw the vertices here um, in our pipeline also uh, gets drawn counterclockwise, and that means that the let's see if I can show you. Let me just change back to the white texture here. I have a white texture which just fills the area completely. Uh, and it means that the winding order correctly starts at this vertex. This is what I specified that I'm supposed to start with. I mean, the 0.0, which is in screen space, the center of the screen. Um, and then it, because of the winding order, it takes the next vertex, which right now in our pipeline is the one where we have a uh, increase over the x coordinate, meaning that we multiply by the x scale and add that to it, meaning that we then draw this one, and then we draw um, this one and this one. And yeah, this is correctly the winding order, but it means that this corner here becomes our kind of like starting point, and I would like for it to kind of like follow the logic where um, um, like UV coordinates in general, because it's just easier to map to UV coordinates. I know the object is moving and it's a bit distracting, but it's because I haven't implemented a sleep method for handling micro collisions. Yeah, it doesn't matter. It's not a bug. It's something that we need to improve on in terms of stability of the physics engine. Anyway, I would like for this corner to be actually the whole thing moved downwards so that this point here is the top left corner. Since our UV map is also specified as this point being 0, 0, and this one point being 1, 1. And yeah, it just gets easier also to follow the logic of why things are done the way they are. Um, we could simply um, change the winding order, but then you have to flip the texture, and then fonts would have to be the texture, the only textures that kind of like uh, um, was flipped. So yeah, I don't think that is a totally great idea. Um, yeah. But then I thought to myself, well, we could just do it in the shader, since then the implementation on the C++ side would be pretty straightforward, and any uh, manipulations in terms of winding order would happen in this shader. So yeah, I played a bit around with it, and if we kind of flip the vertices here, we end up with a different winding order. This would be like this, and this would be like this. Um, let's see. Let's just leave it here. And well, then we have to subtract this instead, because we flipped the y-axis. And now you can see the 0.0 is actually the top leftmost position of this area here. The problem is that now we flip the y-axis. As you will see here, we also flipped the UV. Yeah, the parentheses are supposed to be also in the top of the texture, but they're not. There's a pretty easy fix for that. We simply flip the UV coordinate of the y-axis before we pass it along into the pixel shader. Yeah, and as you can see, everything works now. So yeah, that was the problem we had. Um, this also makes the application correspond to a clockwise winding order for this for uh, the character slash UI generation, and it handles that textures are stored in memory in a flipped way. Anyway, so now we are able to work towards printing our character here. We can start by adding the screen position, we definitely like something way smaller than we just drew. Let me see, let me close this. And yeah, we're back here. So now you can see uh, it's not really that big, but that is because we need to scale the actual UV coordinates. So UV width is going to be the character UV width divided by the font sheet size, the UV height is going to be, of course, the same thing for the height. And yeah, we pass that in to our UV scaling here. And as you can see, we're starting to get something that looks more like a character. Then we need to pass in the UV coordinates. This also needs to be mapped. Actually, let's see. Load. U. We will take the U and the V here. There we go. And we will scale it to our needs. And we have the letter A. If we remove this offset, we should get an A written to the topmost left corner, and that we do. Great stuff. We could do a capital A. Yeah, and this part of the thing controls the actual screen space scaling of the character. So now it, oh my god, I hate that font. All right. So this is the base screen position. We of course need a kind of like X coordinate, which will start at the screen position X, and then the Y coordinate as well. And we will simply manipulate the X and Y coordinates here. Um, let's see. All right. Yeah. For instance, if we wanted to create a for loop here, this will still work. We could also let's see, in our font, not font utils, font types, we can see that whenever we need to advance the cursor, yeah, let's try drawing um, something out here. Let's do a const char pointer to a string, and we initialize it as A and B. Let's see, const char array here. And we initialize that. Let's see, size of, not size of, count of, isn't that, yeah, algorithm, C++, count of array. Yeah. 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 Um, so yeah, we just do the size of, let's see, int count size of the string divided by the size of char. And we simply add that count. Great stuff. Then we have to as in the string index. Let's see. Yeah, so it writes the B. I think it kind of like writes both the B and the A on top of each other. Well, then we update the X and Y at the end. X advance, or rather just the X perhaps. And we of course need to change the buffer information here. And we want to change this to a byte pointer whenever we are done. Where we can add our size of UI element. I times that. So we have our A. Let's see, how many times do we run this? Ran with X. Let's just do this. Yeah, so it's supposed to kinda like let me see, does this actually work? Cast this as a yeah, we update the X. Wait a minute. Wait a minute. So yeah, so we increase the X value. And of course we need to draw our characters here. Um, well, I'm making a mistake somewhere. Maybe it's the way I update the buffer. Let me just check it out in NVIDIA Insight here. I also need to copy this shaders, add the fonts. So fonts and shaders. There we go. And of course we need to check out our vertex buffer UI here. And then we know it's arranged in 4 floats. Oh yeah, okay. Now I see what's wrong. It's not scaled. So we need to scale this by the width in screen space. AB, almost. We also need to calculate the size X. Where we have the width divided by the screen width and the size Y. Let me see, is this correct? I think so. What is it? UV. Yeah, it might be. There we go. There we go. So we have our AB here. We don't need to dump this anymore. And well, the last thing would be to let's see, do something like let's see, uh, uh, where I'm not allowed to do it like that. There we go. I can't remember how to do a null terminated string. Let's see, a literal, yeah, maybe. No. Yeah, it adds the let's see. Yeah, okay. It also needs the I'm unsure whether the UV needs to be. It might be where we draw it. It might be. Let's try that. Well, the line break here. Create non-null terminated string C++. Okay, initialize char array without null terminator. All right, we can also just do like that. -2, -2. Let's try that. FPS. Well, it's still. Let's see, -4 here. I'm not sure. It somehow adds some extra characters somewhere for the array. Is it really 4? Well, okay. I guess I can mess around with that later. It doesn't work in C++. Okay, maybe we can use the std string stringy and let's for now stringy size there we go. That's way better. Alright, so we do it C++ style. Okay. We of course have to we could do maybe just minus the character x offset and minus the character y offset. Let's try that. Well, this also needs to be scaled, of course. Well, let's just, for ease of reading, write it out here. X off y off uh, Well, in our and we of course need to add some padding, I think, don't we? Well, it looks kind of weird. It looks kind of weird. Mm. We can do this times 2 just to get a bit more visibility here. Well, that of course also needs to be scaled on the FPS. Maybe we need to add the, or rather subtract the X offset here. And maybe just Y offset. Well, the semicolon gets better, but the S is kind of weird still. So we think a bit about it. Mm, yeah, we definitely don't need that. Maybe we want to add the X offset and then subtract the Y offset here. It does look better. It does look better, doesn't it? Nah, well, I'm unsure. Well, maybe this needs to be flipped because of the well, Maybe the scaling is also messing things up. Let's try disable the scaling. Well, that didn't seem right, at least. It doesn't look exactly right. Uh, mm, mm, maybe because this is not there. Well, I don't think it's supposed to matter. Um, we could do, let's see. Hmm. Yeah. It doesn't look great. Hmm. Mm. I mean, the Y shouldn't change. Is it just Comic Sans that it is a bad text? I mean, let me try typing out whatever. There we go. FPS. Well, it does look awful even in Paint. But I think the S is a bit the S is a bit too kind of like too kind of like offset. Hmm. Maybe I plus. And without the Y offset here, well, the S is still looking pretty weird. I think it looked better with the Y offset after all. Well, and we didn't have a kerning X offset, Y offset. Let's just print out character. X offset. Y offset. Y offset. Let's try that. So the F has the ID 70. The X offset is 2. And the Y offset is 11. Then we have the P. I think things should be X offset 1, Y offset 11. The S 83 minus 1. 22. Well, for some reason it looks weird. I think maybe we need to add the padding. No, let's see. Load X padding. We do left and right padding. Whoops, right padding. And we kind of do the same for the Y padding here. Top, bottom. And we of course subtract that from our thing here. Didn't change much. I don't think it looked that different. I did a little test with the text FPS. Let's try that. I did a little T, so it for some reason stops. The vertex buffer is not great enough. Let's see when we initialize it, how many vertices do we actually allow in your buffer? Render fonts. Add ones. buffers, max elements. Oh, it's 16. Let's do maybe 200. I did a little test with the FPS. Yeah, it's not looking great, is it? It's not looking great. I'm not unsure whether it's the font or if it's the way that I render this. Bup, 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 bup. Let's close this. We don't need to do the initialization stuff. We don't need to do this. And what happens again if I flip this? Because it looks totally weird. And we don't need to debug that. What if we just do is it a due to the sampling? Or is it due to the texture mapping? Uh, yeah, it's not looking exactly right. Is it the sampling? Uh, let's do a bit of scaling factor. We do the scaling here. We do the scaling on the size. I did a little test. Well, The characters are jumping a bit around. And I didn't change the padding right now. Spacing. Huh. Mm. Hmm. Let's see. Maybe it's the way I did the texture thing. Cliff cache. Uh, um, let's try doing that. And we will. Let's see, when did it get updated? Right now. Let's do the. This is going to be. Yeah. Let's see, and we flip it. And we save it. There we go, we don't need the not flipped one anymore. Let's see, let's just copy this. Did it crash? Yeah, it did. Well, that didn't change anything. That didn't change anything. And what if I only do this? Maybe it's the sampling method. Um, Maybe I want a different sampler because I think I'm using the wrap method and I don't want to use the wrap method. So let's see inside our pipeline. Is it here we define our samplers? Maybe it's in the root signature. Yeah. Let's do another sampler here. Excuse me. Mm. H3, H3. Yeah, whatever. Let's do it for now. We can always optimize. Comparison. Let's see. DirectX12 sampler modes. Address mode. Clamp. I think we need a clamp method. Non-wrap sampler. Let's get the offset back here. And the Y offset back. Yeah. And then inside our shader here. Static sampler. Point clamp. And we do like this. Well, what did happen? Wait a minute. So our root signature here change. Static samplers fall. There we go. Let's try. Well, the sampler method doesn't really seem to work. Is it because I don't? If I use this sampler, and if I use this, well, DirectX, well, static samplers. Let's see. Well, clamp doesn't mirror address mode. Well, maybe wrap is border. Okay, let's try border then. Mm, If I simply set it to wrap, it will work, right? Yeah. But I do think that it's like maybe we're getting rounding errors or something, but hello, welcome. Um, so it seems like the texture kind of gets a bit offset in terms of the UV. Let's just set this to something else and swap back to the. Yeah, it's not getting rendered correctly. I'm messing a bit around with um, how to draw it correctly. Let's see. Let's do the border. Well, we will call it border. We'll set it back to point wrap. Yeah, it's definitely not very nice. I mean the y coordinate. Oh, they are? Yeah, it's probably the Restream application that does that. I've considered swapping to regular multi-streaming. How do you find the video quality? Is it all right? Great. I kind of changed the settings and tried to get a better image so that people are able to see what happened. Well, this just kind of messes it even more up. Thank you. That's great to hear. Um, hmm. Hmm. Oh, that's great. What are you trying to build? Maybe we want to manipulate the UV coordinates here. Maybe that's the problem. Because it seems that it samples the texture a bit wrong. And it samples the texture a bit wrong, so it might be the UV coordinates instead of the actual position in screen space. Yeah, that's great. It's good to start early. I think I was uh, around your age when I started doing a bit of web development. Uh, I wish I held on to it because from the age of, I think, 16 and until I got to maybe 32 or something, I didn't even really I didn't really do any programming. Oh, I don't find you annoying. It's fine. Don't worry about it. Mm. Yeah, so maybe we need to manipulate the UV coordinates here. Mm. Mm. Oh, you find it scary? Mm. Maybe we want to add some padding here. And add a bit of white padding here as well. Let's try that. Well, that looked awful. Um, well, it's still not great. Why is it that you find it scary? Maybe it's just rounding errors. Let me try changing this to floats. Oh, this is a float already. I don't need to do that. This is going to need to be floats. Probably not gonna change anything, but no, that's what I reckoned. Well, they mostly chat GPT and so forth are just language parsers, so they aren't really that great at doing any logic or any planning. So I think AI could probably do some basic programmer work, but once you're an experienced programmer, I don't think that AI can, right now at least, or for a foreseeable future, do anything to surpass that level of experience. And yeah, do anything to like overtake experienced senior programmers. I think at least for the next decade, maybe we will be using AI as tools to speed up basic tasks, but not replace any complicated human um, decision making. Mm-mm. Hmm. So I mean, there are like small spots where the texture kind of gets sampled in a non-optimal way. I mean, the S here is a tiny bit offset. Same goes for the W. Maybe we need to subtract the padding here. No problem. Just um, kind of like try to learn, and then you will probably be all right. Uh, did it help? No, it didn't really. Hmm. Well, it's not related to the size anyway. It doesn't make any sense here. Maybe I need to offset the UV with the padding actually. Let's try that. Yeah, yeah, I'm doing the text rendering here um, manually. Well, that didn't work. That just made it worse. Um, that also makes it worse. And I mean, maybe I need to flip these. Yeah, well, this is definitely not right. Um, and this is not enough, it seems. Let me just think a bit here instead of just doing stuff. I mean, the small letter A is supposed to be a bit more offset uh, in a downwards direction. let's try fixing that. So we can take the small letter A here, 32, small letter A here. So it has a ID of 97. So it's this one here. The Y offset is pretty big. It's pretty big. But yeah, and if we look at what else needs to be a bit offset, we need to offset the small letter I here, 105. It also needs to be offset by at least some amount. So yeah, maybe we're not translating it correctly. I wonder if the offset is better handled by dividing by the character sheet. Whoops. It still doesn't affect it too much. Let's revert back to this. So the Y offset, maybe it needs to be scaled. Yeah, that's way better. That seems to have fixed it. So the offset needs to be scaled at least. All right. Great stuff. Let's revert back to a scaling of 1. Yeah, and I think this is probably due to the sampling. The text is not looking that great when it's that small. It looks way better here, so it's probably just a sampler that is kind of like ugly. We could try changing the sampler to a more expensive and use strophic. Yeah, this looks better, at least a bit better. Well, but yeah, we're not gonna use the expensive sampler. We're gonna do one last thing here inside our data. We will use the input color or RGB and the sampler alpha. And now we can color our text. Let's see. Let's do it red. Yeah. Okay. And let's do it a bit bigger. And then let's simply do something like this, and then bring append. Let's see. Thank you. No, it's a bad habit. So we add the numbers here. And let's do a well. Do we have integer to string? Oh, what is the method? I can't remember. Integer to string C++ to string. Yeah, okay. Is it std string to string? And let's do this. We append the string with the number. And it's obviously not our FPS here. Let's see our render step. We could grab it inside our pass buffer, because the first, or rather the, yeah, I think we just grab it from our pass buffer. And I of course mean the time step, since we will use that to calculate our FPS. And we store the information. Well, oh, the object itself is hiding what kind of type it is. So it's pass data. I'm streaming, yeah. I'm streaming on both YouTube and Twitch. So if we cast our thing to a pass data pointer, and we ask for the delta time, we now have our I think on the channel there's a link to the Twitch. I do prefer to stream on YouTube, but I'm using the Restream IO application to stream on multiple sites. But yeah, as I've mentioned, I've considered doing regular multi-streaming. No, 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 it's fine. You don't need to donate. But this is live also, so yeah, I'm streaming both here on Twitch and oh wow, that doesn't look great. It changes too fast. um, let's just cast this to an integer. Mm, okay. And let's see how many frames we get when I disable vsync. Uh, uh, I can't remember where I put it. There we go. So in debug mode, we get, oh, I need to disable that. That costs us a lot of frames. Okay, around 3 or 4,000 frames in non-release mode. And yeah, almost 5,000 frames per second. It's so fast that you can't really see anything. Um, well, that's great. Anyway, we now have a maybe we need to clear the buffer before we update it. Maybe that's, let's see, zero memory destination. And the length is we do it before we do anything times the UI elements. Maybe that. If we don't clear the memory, didn't it just look more smeary? I think it does look more smeary, but well, it doesn't matter actually because we only render whatever amount of characters we want, so the buffer shouldn't overflow. It's simply because we have too high of a frame rate, I think, to kind of like really get a stable number. But yeah, we have around 4 to 5,000 FPS. which means that we have a lot of wiggle room in terms of doing work on the CPU. I think even we could achieve way higher frame rates if we did some optimization of the draw calls, but or rather the render loop. We could do frame buffering where we would generate frames in flight and utilize the GPU resources way more efficiently, but yeah, there's no need for it right now. And it would only complicate things. It's great. Um, Usually people turn mostly into YouTube, so there will be other people from time to time here in the chat on YouTube, I think, which has been more quiet lately. And I think what you see here on YouTube will be exactly the same as Twitch. All right. So this leaves us at a position where um, we could start drawing basic UI elements. At least we are done doing the text rendering. And in a previous episode, uh, we did the generalized rendering of UI elements. Um, so yeah, the plan is to do a sort of UI system. I can't believe it's still Comic Sans. Where we got we should be able to do squares, bordered squares, text rendering, input polling, slash mouse over if registration button clicks. So for instance, we would like to be able to draw something like a button where we are able to click it. Uh, where it perhaps would do something like that when we click it. So that's the general idea. We need to build a system API of sorts that automates all this stuff for us. And then, of course, we need to pass it to the renderer. We did some basic structures for rendering different stuff. Yeah, maybe we need some structures. And maybe we need to start doing a bit of refactoring of this whole program. Yeah. Yeah. But I've been going at it for about a couple of hours and I need to grab something to eat. Yeah, I'll be back probably in half an hour, 45 minutes, maybe an hour. So I'll end the stream, but if anyone watching along found it helpful, interesting, or entertaining, feel free to comment, like, or subscribe. Yeah. Hopefully I'll be seeing you in the next episode. All right.